Module 5, Section 3.3, Future Value of an Annuity and Sinking Funds. Objectives. Objective 1, compute the future value of an annuity. Objective 2, understand sinking funds. Objective 3, approximate interest rates for an annuity. Future value of an annuity. An annuity is any sequence of equal periodic payments. If payments are made at the end of each time interval, then the annuity is called an ordinary annuity. Future value of an annuity. The amount or future value of an annuity is the sum of all payments plus all the interest earned. For example, suppose you deposit $100 at the end of every 6 months over 3 years into an account that pays 6% compounded semi-annually. How much money will be in the account after the last payment is made? Future value of an ordinary annuity is calculated using this formula. Future value equals payment multiplied with 1 plus I power n minus 1 over I. Here I is the interest rate per period. N is the number of payments. FV is the future value. PMT means the periodic payment. Let's do an example. Find I and N for the following annuity. Monthly payments of $100 are made for 8 years into an annuity that pays 9.5% compounded monthly. So notice that the interest rate is given as 9.5% compounded monthly. I is the interest rate per period, so we need to divide the annual rate by 12 because there are 12 months in a year. The number of payments will be M multiplied with T, where M is the number of periods per year, which is 12, multiplied with the number of years, which is 8. So we get 96. Use the future value formula to find the indicated value. N equal to 19, I equal to 6%, payment is 250. What is the future value? Notice that I is given directly. So we use the formula payment multiplied with 1 plus I power n minus 1 over I. So when we substitute, we get the final answer to be 8,440. Let's see how we can enter this in the calculator. 250 multiplied with, now we need to use a parenthesis, one more parenthesis, 1 plus 0.06 to the power 19, then minus 1. So that will be the entire numerator. So we need to close the parenthesis one more time, divide by 0.06. So we get the answer to be 8,440, rounded to 2 decimals. Next example. Use the future value formula to find the indicated value. This time we need to calculate the payment. So coming back to the formula, we need to solve for the payment. So if I cross multiply, we will get future value times I divided with 1 plus I power n minus 1 as the payment formula. So payment equals future value multiplied with the I divided by 1 plus I power n minus 1. So substitute the given values. 7500 times 0.035 divided with 1 plus 0.035 to the power 32 minus 1. So you need to enter this in the calculator carefully. So we are going to multiply 7,500 with the per period interest rate, which is 3.5% or 0.035. 0.035 divided with, now notice that the denominator contains more than one term. So we need to actually include that in a parenthesis. 1 plus 0.035 power 32 minus 1, and then close the parenthesis for the denominator. So we get 130.81, again rounded to 2 decimals. In the next example, we need to find the value for n. So again substituting in the formula, we get the equation 13,000 equal to 500 multiplied with 1 plus 0.05 to the power n minus 1 divided by 0.05. So I will get 10,000 when I divide 500 with 0.05. So this 10,000 is the value for 500 over 0.05. Now what I did is I divided with 10,000 on both sides and added a 1. So they will get 2.3. So 1.3 equals 1.05 to the power n minus 1. So if you add a 1, I will get 2.3 here. So in order to calculate n, which is in the exponent, I need to take the logarithms on both sides. So natural logarithm of 2.3 will be equal to n multiplied with the natural log of 1.05. So the n value is calculated as natural log of 2.3 divided with natural log of 1.05. Using the calculator, we get 17.07. Here is another example. Suppose a 1,000 payment is made at the end of each quarter and the money in the account is compounded quarterly at 6.5% interest for 15 years. How much is in the account after 15-year period? So we are speaking about the future value. Payment is 1,000. So we need to calculate the interest per period. So that will be the value for I equal to annual interest, which is 6.5%, 0.065 divided by number of interest conversions will be 4 because it is given as quarterly, divided by 4. So that is the value for I. Substituting here, we will get 100,336.68 as the future value. Suppose we want to find out how much interest was earned over the 15-year period. We know that during the 15 years we make 60 payments. 15 multiplied with 4. And a total payment of 60,000. And the total value in the account is 100,336.68. So if we subtract the 60,000 payment made, the remaining amount will be the interest. So the total interest will be subtracting 60,000 from the total amount. We get $40,336.68. What is the value of an annuity at the end of 10 years if $200 is deposited at the end of each month into an account, earning 8.5% compounded monthly? How much of this amount is interest? Same kind of problem. So we have number of payments will be 12 multiplied with 10, 120 payments. I value is 0.085 divided by 12. So we come back and substitute that here and we will get 37,627.68. So how much of this amount is interest? So we need to calculate the total payments, which will be 120 multiplied with $200 each. So we get 24,000. So this is how much we paid into the account. Total payments. So the interest is going to be subtracting 24,000 from 37,627.68. So which is 13,627.68. Sinking funds. An account that is established for accumulating funds to meet future obligations or debts is called a sinking fund. The sinking fund payment is defined to be the amount that must be deposited into an account periodically to have a given future amount. Sinking fund formula. The future value equals payment multiplied with 1 plus I power n minus 1 over I. So if we solve for the payment, we will get the sinking fund payment formula. Payment will be equal to future value multiplied with I divided with 1 plus I power n minus 1. Here is a sample problem. How much must Harry save each month in order to buy a new car for $12,000 in 3 years if the interest rate is 6% compounded monthly? So here we are speaking about the monthly payment. The future value is 12,000. So we can directly substitute here 12,000 multiplied with, again the monthly interest rate will be 0.06 divided with 12. So once we do the arithmetic, we will get $305.06. Approximating interest rates. Mr. A has deposited $150 per month into an ordinary annuity. After 14 years, the annuity is worth $85,000. What annual rate compounded monthly has this annuity earned during the 14-year period? Again, we work with the annuity formula, substituting the given values. Future value is $85,000. Payment is known, which is $150. The only unknown in this problem is the interest rate I per period. So we keep it as a variable. When we simplify this further, we will get 85,000 over 150 equals 1 plus I power 168 minus 1 over I. In order to graph this function to compute I, I'm going to change I to x because we are going to use the calculator here. So we need to solve this equation for x, which is the same as I. Once we do this, we'll get the I value to be 0.01253, and if we multiply this with the 12, we will get the annual rate, which is 15%. So this is how we use the calculator to solve this equation. As y1, you type in the formula 1 plus x to the power 168 minus 1 divided by x. As y2, we are going to take 566.67, which is the other side of the equation. Now if we adjust our window, we can take x minimum to be 0 and x maximum to be 0.1. We know that x has to be a small number. And y minimum is 0, y maximum is 650, because we need to plot this point 566.67. So we will get the graph like this. I want to find out where these two sides are equal, these functions are equal. So I need to go to the intersection of the two curves. Number 5, if you press enter 3 times, it will calculate the intersection point. So the x value is going to be 0.01252947, which is what you are getting here in this graph.